All right. Do we have any questions for any of the speakers?
Back. Oh, in front.
Down. Smith, there was a question at the back.
Here, all the way in the back.
Hello. My experience is with, South African experience, is with using a pressure pot and versus conventional NPK nutrition. My question to you is there any reason to believe that weekly fertigation, application of a soluble fertilizer is any different to applying daily or even amounts as per the previous system, which is all nicely balanced and the same?
Okay. That question is for me or for...
I don't mind who answers.
For anybody.
Okay. I'll just repeat the question. The question is there an advantage in fertigating daily or weekly? Is there a time effect on the frequency of fertigation? Is that right? Yep. Does it make a difference? Okay. Anyone like to answer the question?
The first question I have back is this for soilers or soil? Soil. Okay. Given the large buffer you have in the soil, I would say it doesn't make difference for the crop. Well, of course, we can argue a little bit about it, but this is my straightforward answer. There are some details which can be considered later on, but in general, I won't say there is any difference.
Okay. Are there any more questions? Okay, Paki.
I have a question for you, Rodney. You mentioned an accumulation of available phosphor in the soil. Should it be unavailable phosphor? And how big is the problem here in Almeria?
Okay, that was from a study that was more a survey. They went to different greenhouses and they examined the nutrient content. I think that was an Olsen extraction. And I can't remember the size of the values, but it definitely showed there was an appreciable accumulation. But the magnitude, I don't really remember, but it just indicates that there are reserves that could be used and that people are continually adding to that excess that's already in the soil.
Voy a hablar en español. Esto más que nos pregunta es un poco para hablar un poco de debate. Ronnie, tú has comentado que aquí en Almería los agricultores utilizan mucho los tensiómetros y también has dicho que el agua de riego cada vez es más salina. Entonces, ¿tú crees en el futuro el uso de los tensiómetros debería ser reemplazado por otros instrumentos? ¿Qué tipo de instrumentos a lo mejor puedes recomendar en condiciones de elevada salinidad del agua de riego?
Okay. All right. The question concerns the use of soil sensors, in particular tensiometers, when there's an increasing problem of salinity. Tensiometers aren't really affected by salinity. So when salinity becomes a problem, there's definitely a need to take into account the soil solution. Well, there's different approaches. One is to consider the soil salinity, for example, regularly with another system, for example, by monitoring the soil solution with suction samplers. Another approach is to use sensors that can measure, for example, the volumetric water content and the soil salinity, but then that becomes a little bit complicated because those sensors are less accurate and there's a problem with converting bulk soil electrical conductivity into the soil solution electrical conductivity, or something that people can readily understand. So I think at the moment, the best approach I'd suggest is continue working with tensiometers but paying a lot of attention to the salinity in the soil solution.
Un comentario a lo que ha dicho Diego y Ronnie. Yo pienso que los dos tipos de sensores son necesarios. Los tensiómetros dan una visión de la fuerza que tiene que hacer la planta para capturar ese agua libremente en el sustrato, mientras que el otro tipo de sensores lo que te miden es la cantidad de agua que hay en el suelo. Son dos conceptos, son dos matices distintos pero complementarios. A la hora de gestionar el agua de forma eficiente, tenemos por una parte saber qué volumen de agua disponible hay en el suelo y evidentemente la salinidad va a modificarlo, porque ese efecto osmótico va a reducir ese agua libremente disponible. Y por otra parte hay que ver qué capacidad tiene la planta para capturar ese agua. Eso es lo que nos dan los tensiómetros. O sea, hay que... Desde mi perspectiva hay que llevar los dos para adelante.
Okay. If I understand, the first part of the question was to do with the use of sensors to estimate the amounts of water to apply. Yeah? Okay, because generally sensors can tell us when to apply. The amount of water becomes more complex, particularly when we have drip irrigation, because we have a very heterogeneous distribution of water in the soil. So what we're measuring with our sensor is not representative of the whole area. So it's really a question of people perhaps calibrating mentally what the conditions are and how much they apply. And that's not so difficult. You know that if you've arrived at negative 40 kilopascals and you need to irrigate, and you apply so much, you can see you've arrived at minus 10 wherever you want to be. So that's something that I know people are working on programs that do that. I think the program that the Cajamar is working on with Sysitex and ITA is trying to calculate the actual amounts. But I think it requires some pretty good software.
Ya, pero, a ver, otra cosa es que el tema es un poco más complejo. Evidentemente, la necesidad de agua de la planta varía a lo largo del día según la demanda hídrica ambiental. Depende también del desarrollo fenológico de la planta y de la competencia hoja-fruto. Pero también hay otros aspectos que no se han considerado aquí y son las diferencias genotípicas. No todos los sistemas radiculares de una misma variedad de tomate tienen la misma capacidad para capturar agua. Hay todo un proceso de, vamos a llamarle, tuneo, que modifica la conductividad hidráulica y hay una investigación muy intensa en el tema de acuaporina y de la arquitectura de la raíz, de la morfoarquitectura de la raíz y de la densidad de pelos radicales, que está muy condicionado por el tipo de sustrato, por el genotipo, por el escenario de cultivo. Y si vamos a una agricultura de precisión, todos estos aspectos hay que tenerlos en cuenta.
Yeah, the question, as I understand, is about taking into account the distribution of the root system, etc., when applying irrigation, interpreting sensors. Is that correct? Well, yeah, but I think one of the advantages of sensors is that if they're used correctly and positioned correctly, you can take into account the characteristics of an individual crop. You can really put the sensors where the roots are most concentrated, and you can tell where the roots are most concentrated, there is now an approaching lack of water or deficiency of water, and it's time to irrigate. So I think they do provide a lot of adaptability to take into account those issues. But yeah, sure, we should try and optimize the distribution of roots, etc., which hasn't been a high priority recently.